Hello everyone. So today what we're going to do is have a little crash course on the use of MATLAB. So we're really going to scratch the surface and see how we can create variables, create arrays, vectors, matrices, plotting, as well as some programming logic, looking at conditional statements and loop statements in MATLAB. So when you open MATLAB, it should probably look something similar to this. So here in this window, this is what we call the editor, so this is the editor where you can save a script. So a script is a small little program that MATLAB runs. Down here is the command window. So everything here is done in real time, and it shows the output of your script up here. And here on the right is your workspace, where variables and everything that is stored in the system memory is shown over here. So it will show you the size of the variable, or let's say the array that you've created, and also the type. So if it's an array of characters or an array of double precision numbers. Okay, so the first thing we're going to do is look at variables. So I would encourage you in MATLAB to consider using comments as much as possible. So comments are things that MATLAB does not evaluate. They're just helpful to make the program a bit more readable by humans. So for example, if I want to create a title here, I can just say this is a sample MATLAB script. And you see this is in green, and that is because it's following this special symbol here, that when MATLAB encounters this %sign, it knows that it is not supposed to evaluate what comes after it on the same row. So this is just a comment that will help you understand your MATLAB code a bit better. And it's very useful, especially if you've created a script and you come back to it a month later. Sometimes it's difficult to understand what you did. And so if you commented well, you can get back into your workflow a lot more quickly. Okay, so let's look at creating simple variables first. So if we want to create a variable and assign it a number, this is quite simple to do. So let's say we have variable a, and we want to assign it a value of 1. So a can be anything from your age or the length of a link, and so we're assigning it the value of 1. So now if we run our script, which is here, it will output the results of the script down here. So we see a is equal to 1. Now if we want to suppress the output, we can just put a semicolon behind our statement. So if we hit run, we see that it has not output what is in the script here. But in the workspace, you can see that we have a variable a which has a value of 1. So this is essentially the memory taken up by what you are doing here in your script. If we want to create a second variable, so let's say b is equal to 2, we can do that. So as you can see, b has appeared over here. So if we want to clean up our command window, what we can do is write CLC. CLC clears the command window. If you want to do this every time you run your script, you can put CLC at the top of your script. Okay. So if we were to have a is equal to 1 and b is equal to 2, and I'm not suppressing the output, then we're going to have a is equal to 1 and b is equal to 2. If I didn't have the CLC statement, which clears all the output from the command window, and I hit run again, you're going to see that it's starting to get a bit messy. We have a is equal to 1, b is equal to 2 from the previous evaluation, and again, a is equal to 1 and b is equal to 2. However, if I keep the CLC here, which clears the command window, and I run it, we only have this one instance here. So I like to use this. It's good practice. As well, you can write clear, and clear, what this does, it clears the memory in your workspace. Okay. So I like to have these two statements at the beginning of each of my scripts, but it's not necessary. So we have created two variables, a and b, and let's see if we can perform some arithmetic with this. So why don't we say c is equal to a plus b? And we're not going to suppress the output because I'm not interested in a and b, I'm really interested in c. So we're going to get c out here, which is equal to 3. Okay, so pretty simple. I can say d is equal to a times b, and we're not going to suppress the output for this, and see what this gives us. So we have two outputs. We have c, which is equal to 3, which is a plus b, and d, which is 2 times 1, a times b, is equal to 2. Pretty straightforward. Using variables, we can also evaluate trigonometric functions. So for example, let's say we have e is equal to 2 pi. And why don't we evaluate? Let's assign to f the value of the cosine of 2 pi, which we have attributed to variable e. So f is equal to the cosine of e, where e is equal to 2 pi. And we see that f is equal to 1, which makes sense. The cosine of 2 pi is 1. Okay. So by default, the trigonometric functions take as arguments in MATLAB angles which are in radians. So keep that in mind. You can change this in MATLAB if you wish, but just be aware of what the default is. So why don't we add a comment here, and we say this is creation of variables. And let's suppress the output because I really don't, we're going to move on to something else right now, and I don't want to keep seeing this, but I want to keep this up just for future reference. So why don't we look here now at array creation. An array is a matrix. So let's say we want to create a matrix, or a matrix which has 1 row and 4 columns. So we're going to say A is equal to 1, 2, 3, and 4. Okay, let's see what this gives us. So we run this, and we see variable A is a matrix which has 1 row and 4 columns. If we want to create a matrix with more than just 1 row, this is pretty straightforward. So let's write the first row, which has 3 elements. And to access the second row, we just put a semicolon here, and we're going to write 4, 5, and 6. And let's make this a square matrix, and we'll write 7, 8, and 9. And we'll see what this gives us. So as you can see, matrix B is a 3 by 3 matrix, so 3 rows and 3 columns. And we were able to do this by using a semicolon within our brackets here to enter the new line. So let's say I want to access one of the elements of the matrix. So let's say I want to access the element in the second row and the third column, which would happen to be this one right here. Okay, so I can create a new variable if I want, element, doesn't matter, you can call it whatever you want. And I'm going to say I want from matrix B, I want the element in the second row and the third column. And so I'm not suppressing the output, so I didn't put the semicolon because I want to see it out here. So this gives me element is equal to 6. So from the second row and the third column. Now you don't need to keep outputting the values in the command window. So you can put a semicolon here and just run it, and you can see that element is equal to 6 over here in your workspace. So it's up to you how you decide to look at your results. We can operate on matrices as well. So why don't we say matrix C is equal to the sum of matrix B plus a scalar, which is 10. And let's see what this gives us. So as you can see, every element of matrix C has been increased by 10. Okay, so that's very straightforward. You don't need to access every individual element from matrix C and add 10 to it. It does it automatically. It knows to add this scalar to every single element of matrix B. Now, if we want to multiply it by a scalar, so let's say we want to multiply matrix B by a scalar of 100. So we'll just say 100 times B and see what this gives us. So everything has been increased by a factor of 2. Okay. So let's say we want to invert a matrix. Okay, so I don't think this is a very clean matrix to invert, but we'll give it a shot anyway. So we're gonna say that matrix inverse. So this will be the variable for our new matrix, and I want to take the inverse of matrix B. So all I have to write is inv of matrix B, and it will give me the output. So yes, as you can see, it is not a very clean matrix to invert. It is invertible, but you're getting a warning from MATLAB that it is close to singular, but that's okay. So in the course that we're taking here, you know, the matrices that you might need to invert are definitely invertible. So as you can see, it's a very simple command. Inv of matrix B will give you the inverse. You can transpose a matrix if you wish. So why don't we write matrix transpose? So I want the transpose of B. So all you have to write is B. And for MATLAB, we just use the apostrophe to say transpose matrix B. And let's see what this gives us. So now in your command window, you can see that it has been transposed. So the rows, so row 1 has become column 1, row 2 has become column 2, and so on and so forth. Okay, so I think we're going to move on to plotting in MATLAB. So I'm going to create a new section here, which is MATLAB plotting. So why don't I create a variable which I'll name theta, okay? And I'm going to say that theta goes from 0 to 2 pi, and I want it to have 360 elements. So in MATLAB, we use what is called linspace. And what this does, it creates a linearly spaced vector. So the vector is essentially broken up into even segments. So linspace, and we're going to go from 0 to 2 pi. So this is the syntax. So this is the minimum value of the vector theta. This is the maximum value of the vector theta, and I want 360 elements. So if I hit run here, you're going to see that theta goes from 0 to 2 pi and has 360 elements. And you can see this in your workspace here. So it's a vector of 1 row and 360 columns of type double. So now let's say I want to perform an operation on theta. So I can say that y is equal to the sine of theta. So if I hit run, you can see that y now has a length of 360 elements as well. So it has essentially performed the sine operation on every single element of the vector theta. So that is why we have a length of 360 for variable y. I create a new variable z, and that is equal to the cosine of theta. And let's suppress the output. So now let's see if we can plot this. So in MATLAB, if you want to plot it, you can create a new figure using the word figure. And we're going to say plot. And the nice thing with MATLAB is that you often get help as you move along in your script. So if you just wait a second, you get this pop-up box over here, and it kind of tells you what you need to input for this function plot. So function plot requires your x variable and your y variable that you're plotting, and line spec is essentially some specifiers that help define what your curve looks like. So if it's a solid curve or if it's a dashed line, also what color you want to plot, etc. And we're going to see that. So we want to plot x, which will be theta, versus y, which will be y in our case, which is the sine of theta. And let's see what this gives us. So you hit run, and you get your standard sinusoidal plot here, going from 0 to 2 pi. So the curve was blue, but let's say we want to change it to red. All we have to do is, between these two apostrophes, put the marker R here. And what this tells MATLAB is that I want a red curve. If I don't want a solid line, but I want a dashed line, all I have to tell MATLAB is that I want a dashed line using these two dash marks right here. So now I have a dashed red line. I can add labels as well. So if I want to add a label to my x-axis, all I have to do is x label, and I can say that I want x to be theta. So having a look at what we have, now we have theta down here. So let's say I want to have both the sine and the cosine plotted on the same figure. So by default, what MATLAB does is that it will update the figure with the latest plot command. So it will overwrite the previous plot command. So if I hit run here, you're going to only see the curve for theta versus z, where z is the cosine of theta. But I want to see both at the same time. So what you need to tell MATLAB is to hold on. And what this does, it will prevent MATLAB from overriding the previous curve, which is y versus theta, with the new curve z versus theta. So now if we look at our plot, we have both. We can add a legend as well. It's pretty straightforward. So we write legend, and it knows that, you know, the first element of your legend will be associated with the first curve. So why don't we write this will be sine, and this will be cosine. we have our legend here on the top right, and it tells us that the dashed red line is the sine curve and the solid blue line is the cosine curve. Pretty easy, pretty straightforward. Okay, so let's move on to loops and conditional statements. So what a loop does, it tells MATLAB to evaluate a certain statement many different times for the variable which we are looping over. So it is hard to describe without doing an example. So let's write a for loop for the variable I going from 1 to 10. So a for loop begins with the for statement and ends with the end statement. So we have a variable I which will take successively the values going from 1 to 10 with an interval of 1. So it'll be 1, 2, 3, 4, 5, and so on. So what we're saying is that for each value of I, perform whatever we're saying within this for loop. So for each value of I, we're going to say, why don't we say we have variable zz, which is equal to 2 times the value of I. I'm just going to comment this out so that we don't get a figure every time we're hitting the run button here. So for each value of I, assign to the variable zz the value of 2 times the value of I. So for example, when I is equal to 1, zz will be equal to 2. When I is equal to 2, zz will be equal to 4. And notice that I wrote zz of I, which means that zz is going to be a vector of the same length as the length of I, essentially. So I can take on 10 values. So zz will be a vector with 10 elements, each element having the value of 2 times I. So let's output the final value of zz down here and see what that gives us. So we see that it has looped 10 times, and when I is equal to 1, zz is equal to 2. When I is equal to 2, zz is equal to 4, and so on and so forth. So notice that had I not put this bracket here with the index I, so I just said zz is equal to 2 times I, and we run it. Notice that now our variable only has one element, because what this is doing is just updating the value of zz at each loop and overriding the previous value. But if we want to create a vector for each value of I, then we need to add this little bracket here with the I. So we can look at a conditional statement. So what we can say is, okay, loop for I going from 1 to 10, but if I is less than 5, then perform this operation, so multiply it by 2. Else, we can say zz of I is equal to 4 times I. And just like the for loop ends with an end statement, an if statement must also have an end statement over here. And let's see what this gives us. So when I is less than 5, we're multiplying I by 2 and assigning it to the element zz of I. So we have 2, 4, 6, and 8. But then once we get to I greater or equal to 5, we're multiplying it by 4. So we have 20, 24, and then 28, 32. So that'll be 8 times 4, then 9 times 4, and 10 times 4. Okay. So this is what we call a conditional statement. So conditional statements, often we use if statements. So we have if something is less than or equal or greater than or whatever, then perform this operation. Otherwise, perform this operation. Okay, so this was a basic introduction to MATLAB. We have looked at a few fundamental concepts when creating MATLAB scripts, such as the creation of variables and basic arithmetic. We've looked at creating arrays, how to access individual array elements and perform operations on these arrays. Next, we looked at plotting in MATLAB, which is very straightforward to do. And finally, we looked at loops and conditional statements. So I hope this was helpful. As always, I am happy to meet with you if you have any questions or concerns, or if you need help with MATLAB syntax or the logic in creating MATLAB scripts to solve engineering problems.